is really big.
Yours is really big?
Yeah.
Mine is small.
Okay, yeah, my graph. Yeah, what do I think we did?
What does it mean with respect to our data?
I mean, I started with a lot of acronyms.
Then it's kind of close to our trial zero,
Mm-hmm.
ish,
Ish.
ish.
Yeah.
Oh,
No, so these mine.
yeah, they must have been, okay. So let's just do 0 now, I guess. Can we just do that?
Is it plotting yours instead of his?
There we go.
There you go.
Okay, and now,
So then go to,
did I jump ahead?
yep, that's it.
No. Okay.
Oh, I think our A's
A lot.
are way different.
Yeah.
What do you think,
Did you get your equation?
Is yours not working?
Can't get
What do
the
you think
equation.
of that? I mean, what a smart one.
Yeah. I was just gonna say it represents the y-intercept.
Yeah.
Okay, no problem. No problem with it. So the two tables were mixed up together.
Oh, like the wrong coordinates?
Well, some of his data points were on my list as
Oh.
well, because my list was much shorter once I did it the proper way.
Alright, so we got 0, we got 71,
Good.
144, 23,
Mhm.
12,
Yep,
8,
yep,
3,
yep.
1.
Good. There we go.
Okay. So, what should be?
Hmm?
This is your, I said, what's the value of B?
Okay,
How does this
that
relate
works.
to the
Okay.
information?
That'll work.
There we go. Thank you.
I don't know about relating it to the information I collected.
Yeah, I don't know either.
What question?
How does B relate to the information we collected?
Can you see a pattern in the numbers that you collected?
I mean, mine decreases. I went through my trials.
And do
Mine
they,
gets smaller.
so they get smaller?
So it should be a small number, because if I kept going and going, I'd get like a piece of it.
Right. And is there a certain amount that it keeps decreasing by?
Okay.
Probably. So this number.
Now we.
So
I would guess.
Okay,
Okay.
so
Alright,
this is
so
how
graph
this
yours.
decreases.
You could test it out and see if it works.
Okay.
So, here's your- oh,
Well,
that's
that's-
two.
That's fine.
Okay.
Seven,
Okay, so yours is growing and mine,
Getting smaller.
yeah.
Okay. So what do you think?
I mean, yeah. Yeah.
It's hard to get my.
Or if it's in my ratings,
What is this
sure.
one with respect to the data?
Thanks.
So that's your starting point, wasn't it?
Yeah, I mean, it's close to my data, so it's a good number. it decreases by each time, so it's
Yep,
gonna be
when
this.
X is zero, my is.
Does it
Mhm.
decrease by that number?
Yeah, because
Or
it's
what did you
starting
do to
point.
figure that out?
I multiply the number in this by this to get this.
So, it doesn't decrease by that number, but it decreases, right?
By the average, yeah.
Why is that?
My five. Yeah. Yes, okay.
Okay. Oh, yeah, we just answered that, though, right?
Mm-hmm.
0,
Yep.
6.
So what was yours, 86?
86.94, yep. Okay, and now see what is the value of the LDR rate. Cause mine almost reduced by half
Mm-hmm.
each time, close to it,
Mm-hmm.
and yours, I assume. Oh, you read it different.
It was the double, and I swap one,
Okay.
two, and two, but in, right double. Right.
Oh, cause yours was, the whole trial was set up differently to be, it was supposed to be double, okay. So B is minus category.
Yep.
Can I borrow that sheet? Okay.
When you're done with yours, you can help yourself to mine if you want.
Do you not like a line?
No, I don't. I don't eat candy.
Oh my goodness.
Sorry.
You better less.
Well, I don't know about that.
Well, I don't shoot
I had to change my diet 4 years ago.
that. I couldn't give up.
I didn't think that I could either. I did. And you had a
I had,
growth rate.
bonus on 4.3.
I'm assuming that mean that mine represents exponential growth.
Yeah, I would think that mine
Mm-hmm.
would decrease with us, and it's a lower.
Okay. Which data represents
Yeah,
exponential
no.
growth? You do.
Mine, cause I'm getting big. Right?
Mine's
Mhm.
not.
Oh, that's just what I got.
Oh. Uh-uh.
Mine.
Okay.
Okay.
My M&Ms were big, big, and yours are small.
Mhm.
This one?
Well,
Okay, so would you rather have the M&Ms go linearly or exponentially, and why?
That's honestly.
Oh, yeah, for dollars.
Might be exponential, wasn't it?
But why?
Was it?
I mean, obviously.
My M&M will grow quicker.
No, I'm sorry, it was not. It was just, it's because
So
it's,
you just want
okay,
more.
because I'm less than
Mhm.
one.
You
It
just
was
want
once
more.
it gets small,
That's
so
why
it's
it's
good.
small.
Oh, it's
Suck it.
And then if you guys are done answering your questions, you can write your equation.
Okay.
Up there?
Under there, yeah, so if you started to write it under that column and you started off
So,
right under the other column.
Word. Let's just go with exponentially.
oh, yeah.
Hey, we're all agreeing to go on more. Even if I get more M&Ms, I can trade it for something, right?
You don't like M&Ms?
No, I don't.
I'm sorry, I forgot
No,
like
it's okay.
Skittles or something.
I don't eat candy.
Oh,
I
okay.
had to,
I would have
I
brought
had
it.
to cut out sugar 4 years ago.
Oh. And then if you guys are gonna answer your questions, you can just write, you started to.
Do you ever binge eat sugar?
What?
Do you ever binge eat sugar?
Not anymore, I used to. I was on the whole, we can't? Okay.
Sorry.
You're
The
up.
flaw.
You made mine.
I did, I made it green. I
Should
assumed
we do
the
it?
different colors.
Oh, you can?
Yeah, there's a mode
Some
where it's called
farmers,
dual pitch
yeah.
mode.
You can?
Use
Okay.
use both sides.
Okay, so now we're just gonna go over the questions together as a class. So for part 3A, what did you guys come up with for the value of A? What does it mean? Or represent, if anything?
We felt that it was the starting point, or based on our graph, where the assumed y-intercept would be.
Okay, so the starting point?
Mhm.
Did anyone else have any other ideas? Or did everyone agree with that? Good. Okay. When x is 0, what is the value of your equation?
A?
A,
Yeah.
right? And that makes sense because it's just your starting point times 1. So what does the value of b mean with respect to your equation? Or what did it represent with your data?
We kind of thought that since mine was getting bigger, like that's how much it's getting bigger by. And since Jeremy's was getting smaller, it was like decreasing by that amount.
Okay. And did it actually go up by that number, or how did you figure out that it was?
Well, it wasn't quite just looking at mine. I just kind of guesstimated it was less than doubling, but more than just adding one each time.
Okay.
So I figured it was somewhere in between one and two.
And did you add it to your numbers or multiply it by your numbers?
Multiple.
Okay. So it's kind of like it's increasing or decreasing by that rate in the parentheses, right?
Mm-hmm.
So when we talked about linear functions, how did they change?
Adding.
Yeah, the same every time.
Adding, right? So it's just a constant in this way. It's kind of multiplying, so it's changing by a rate instead of a value. So what did you decide decide is growth, and what did you decide was decay? I think you kind of already answered it, but
Well, like, I started off with a lot of randomness, so, and then I ended up in none, so it's kind of decay. So I'll stop it.
And in your equation, what did you notice made that growth or decay?
Looks like if it's greater than 1, you're gonna have growth, and if it's less than 1, you're gonna have decay.
Awesome. So then, if you had the option to pick whether your M&Ms grew exponentially or linearly, what did you choose?
Exponentially.
Actually,
And why is that?
Who doesn't like it?
sorry.
Is it because they grow faster? Is that
Yes.
Uh-huh.
Okay. Oops.
Thank you.
You're welcome.
assume we have different exit tickets, is that?
It should be the same.
Is it, okay.
Mhm.
Okay.
Okay, and if you're not done with your exit ticket, that's fine. This will be your worksheet for tomorrow.
Thank you.
And then I'll just take your exit tickets and the stuff you worked in class today before you leave. And then we're done, but I think we have like 5 minutes, but we don't need to record the number of sheets for 5 minutes. Okay, sure,